Welcome to The Explainer. Today, we're going to pull back the curtain on something that pretty much runs everything you do online, the RESTful API. Now, it might sound super technical, but it's actually a really elegant solution to a massive digital problem. And we're about to see just how it works.
I mean, just think about it for a second. You book a flight, and boom, it magically shows up in your calendar app. You sign into a brand new website using your Google account with just one click. How does all of that happen so smoothly? How do all these different, separate apps actually communicate with one another?
To get our heads around that, we first need to understand the basic way that different parts of the internet, well, talk to each other. And honestly, the best way to picture it is to think about something we've all done: ordering food at a restaurant.
Okay, so at the very heart of it all, the internet runs on this thing called the client-server model. Just imagine you're the client, and you make a request like, "I'd like a pepperoni pizza." The server is the kitchen. It gets your request, makes the pizza, and then sends it back out to you. This simple back and forth, this request and response, is the engine of the entire web, and it's happening billions of times every single second.
But you know, for any of this to work, you and the kitchen have to be speaking the same language, right? You can't order an Italian at a French restaurant and expect it to go well. On the web, that common language is called a protocol, which is just a set of rules for communication. And the most common one you see is HTTP, Hypertext Transfer Protocol. Everyone's got to play by the same rules.
All right, so this whole restaurant thing, it's a perfect map for how the internet works. Let's break down who's who and what's what.
Okay, this slide right here, this is our Rosetta Stone. You, the customer, you're the client. The kitchen, the place doing all the work in the back, that's the server. Your specific order, carried from your table to the kitchen by the waiter, that's the HTTP request. And the menu, the official printed list of what you're actually allowed to order, that right there is the API.
So here's the really crucial part. An API isn't the entire kitchen. It's not the server itself. It's just the menu. It stands for Application Programming Interface, and it's basically a structured list of everything the server is willing to do for a client. You can't order a steak if it's not on the menu, right? The API defines the rules of what's possible.
Okay, but what happens when you need to pay? You got to give them your credit card info. You're not going to just shout those numbers across the restaurant, are you? No way. You do it quietly, securely. On the web, that's what HTTPS is for. The S literally stands for secure. It's just like regular HTTP, but it wraps the whole conversation in a layer of encryption. It's like passing a sealed, unreadable note that only the kitchen can open.
All right, so this sounds great, right? Every service has a menu, an API. What's the problem? Well, what if every single restaurant in town had a totally different, kind of weird, undocumented way of ordering? What if one place made you sing your order and the place next door needed it written in ancient Greek? It would be absolute chaos. I mean, can you imagine? For the software developers trying to get all these services to talk to each other, it'd be a complete nightmare. They'd have to learn a totally new, custom-built system for every single service they wanted to plug into. Things would grind to a halt.
And this is the exact problem that REST comes in to solve. Now here's a super important point. REST isn't a strict protocol or a specific technology. It's an architectural style. Think of it like a style guide for architecture, like Gothic or modern. It's a set of principles for designing these menus, these APIs, so that they're all predictable, logical, and easy for anyone to use. It really just boils down to a common sense way to build these things.
This whole idea came from a computer scientist named Roy Fielding. Way back in the early days of the web, he saw this potential for chaos and basically said, hey, we need a common blueprint here. His goal was simple. Let's create a shared structure so that developers can work with thousands of different APIs without having to start from scratch every single time.
So the full REST style guide has a few rules, but for our purposes, there are really just two golden rules that are the bedrock of the whole thing. If an API follows these two, we can pretty confidently call it RESTful.
So what are they? Just two simple rules that make an API truly RESTful.
Rule number one is simple. Use the standard HTTP verbs for your actions. Instead of making up your own commands for everything, a RESTful API uses the vocabulary that's already built into the web. A GET request always means you want to read some data. Post means you're creating something new. Plit updates something that's already there. And delete, well, that one's pretty obvious. Universal verbs for universal actions.
And rule number two, you organize your URLs, your web addresses, into predictable paths using nouns. So for example, /articles represents your whole collection of articles. If you want one specific article, you just add its name or ID to the end, like /articles/unique ID. Now, put the two rules together. A GET request to /articles gets you the whole list, but a delete request to /article/unique ID gets rid of just that one. It's just verbs and nouns working together in a way that just makes sense.
Okay, so verbs and nouns. Simple, right? But why is following these two little rules so completely transformative? Why does this even matter so much?
Well, because this shared pattern is what makes the modern web actually work. It makes APIs predictable. A developer can glance at a new RESTful API and immediately get a feel for how to use it. That makes building things way, way simpler and faster. It allows systems built by totally different companies in totally different programming languages to connect and share data without a fuss. It's the reason everything is so interconnected today.
Let's go back to that building idea. REST is basically the rule that says, hey, restrooms are usually marked with a sign and are in a common area. You don't need a custom blueprint for every single airport or mall you walk into, you just know the pattern. REST gives that same common sense pattern to the digital world so we can navigate it without getting lost in a maze.
So when it all comes down to it, this super elegant standard is the invisible engine that lets all your favorite apps play nicely together. It's a design philosophy that picked simplicity and predictability over total chaos. And that kind of leaves us with one last question to chew on. Now that you can see this pattern, what other invisible rules are out there, quietly running your digital life?